the James Webb Telescope has captured something truly astonishing: lights that resemble those from a city, shining from a distant 0.7 trillion miles away. This discovery has sparked interest in the possibility of life beyond Earth. The telescope zeroed in on Proxima Centauri b, the closest exoplanet to our solar system, and found strange, bright lights. Could these lights be signs of another civilization? Let us explore how the James Webb Telescope uncovered these phenomena that will change our understanding of the universe. For a long time, researchers and regular folks alike have been excited to catch a glimpse of what life might look like beyond our own solar system. Any small bit of evidence that hinted at the possibility of something out there was eagerly welcomed. Then came a groundbreaking moment when the James Webb Space Telescope provided clear signs of life somewhere in space. As it explored the vastness of space, this powerful telescope spotted something intriguing on Proxima Centauri b, an exoplanet far away. It noticed lights that looked similar to the lights you see in cities on Earth, suggesting the possible existence of an alien city on this distant planet. This idea has sparked a lot of excitement and curiosity among scientists. They are intrigued because this might just be the kind of discovery they've been hoping for. It suggests that there could be intelligent beings out there, organizing their societies in ways we can't yet fully comprehend, and we're just now beginning to see evidence of it. Looking at these distant city-like lights, which are a staggering 7 trillion miles away, NASA engineers are amazed and wonder how long these lights have been visible in space, just waiting for us to finally have the technology to see them. David Kipping, an astronomer at Columbia University, described the planet where these lights were found as quite complex. This is because, unlike most rocky planets that absorb sunlight and release infrared energy, this exoplanet behaves differently due to its unique relationship with its host star, Proxima Centauri. This finding by the James Webb Space Telescope highlights its importance. The telescope's ability to pick up infrared wavelengths was key in detecting the unusual thermal signature of Proxima b, which is crucial for understanding the planet's atmospheric conditions. Researchers plan to continue using this telescope to delve deeper into the atmosphere of this planet and even explore whether it might be habitable. The James Webb Telescope is particularly sensitive to infrared light, which allows it to observe what happens on Proxima Centauri b during the night. For many space telescopes, it's difficult to detect faint lights in the vast darkness of space, but the James Webb Telescope can see even the smallest glimmers of light. This makes it an ideal tool to confirm whether the so-called city lights on the dark side of Proxima b are real. The telescope can detect any man-made light in space if it falls within a very narrow frequency band, much narrower than regular starlight. Proxima b has a dynamic relationship with its star. On the daytime side of the planet, numerous solar panels capture the powerful energy of the star, and its spectral edge also reflects light. As the planet orbits around Proxima Centauri, it experiences day and night cycles similar to those on Earth, with intense heat during the day and cooler temperatures at night. The planet experiences significant temperature differences, which are largely determined by its makeup. For instance, if Proxima b lacks an atmosphere, the temperature difference between day and night would be extreme. Without the moderating effects of atmospheric gases or oceans, the day side would get extremely hot, while the night side would fall into freezing temperatures. This dramatic temperature variation is a key area of interest for astronomers as it offers insights into the atmospheric composition of Proxima b. The James Webb Space Telescope, with its unmatched infrared imaging capabilities, can effectively analyze the planet's thermal emissions, providing valuable data on its atmospheric properties. Interestingly, the orbit of the James Webb Telescope around Earth matches the orbital period of Proxima b, allowing for comprehensive observations of its day and night every 11.2 Earth days. If the planet indeed has an atmosphere, the next step will be to examine its atmospheric chemistry to determine if it can support life. Signs such as the presence of oxygen, water vapor, and methane would indicate habitable conditions. If these elements are present on the planet, it would confirm its potential to support life. This requires precise capture and analysis of light passing through the planet's atmosphere, a challenging task. Although the James Webb Telescope has excellent capabilities, the James Webb Space Telescope, although primarily designed for other tasks, plays a significant role in characterizing planetary atmospheres. It specializes in analyzing variations in the concentrations of water vapor, carbon dioxide, and methane. While it has limitations in detecting bonded oxygen, a crucial indicator of life, the telescope is also equipped to search for other important elements like ozone, which is a good indicator of a healthy atmosphere. As scientists consider the James Webb Space Telescope's findings, the search to explore faraway worlds grows, bringing us closer to knowing if we're alone. Exploring new worlds with Webb. The James Webb Space Telescope can only observe a limited number of the closest habitable worlds to Earth. For more detailed atmospheric studies, astronomers are turning to ground-based observatories like the Extremely Large Telescope, ELT, which is set to begin operations in 2028. The ELT is designed to provide deeper insights into the atmospheric structures of distant exoplanets, offering detailed and clear data on their potential to support life. Scientists are eagerly waiting for the operation of future space telescopes like the ELT. In the meantime, however, the James Webb Space Telescope remains an essential tool in our quest to explore distant exoplanets. Despite its limitations, the Webb telescope continues to offer profound insights that could revolutionize our understanding of what lies beyond our solar system, both now and in the future. Researchers have big plans for the space telescopes of tomorrow. They aim to reduce the bright glare of stars so they can get a better look at the planets orbiting them. This technique will help analyze the planet's atmosphere and check if it could support life, though this task isn't straightforward. Scientists must differentiate between gases produced by living organisms and those from natural planetary activities, like volcanoes. They are committed to understanding these far-off planets better, so they can identify real signs of life and not be misled by natural processes. The Webb telescope is giving us a sneak peek at what these future studies might uncover. As we continue to push the boundaries of our knowledge and exploration of space, we get closer to understanding the complex universe and our place in it. Since the dawn of time, humans have wondered if we are alone in the universe. This question still drives many scientific studies today. Right now, the James Webb Telescope is out in space, observing different planets and moons to see if any might harbor alien life. Many now believe that aliens might exist somewhere in the cosmos, just waiting for us to discover them. To help answer this age-old question, two American astronomers, Jill Tarter and Thomas Pearson, started the Search for Extraterrestrial Intelligence (SETI) project in 1984. They set up a non-profit organization to listen for radio waves from space, believing these signals could travel far without being absorbed. Despite searching for over 30 years, SETI has not yet found any definite radio signals from aliens. But Jill Tarter remains hopeful, believing that today's technology might finally uncover something. She encourages everyone on Earth to join in the search for extraterrestrial life. Recently, excitement grew when NASA reported that the James Webb Space Telescope might have detected city-like lights on a nearby planet. The JWST is currently our best tool for space exploration, positioned 1 million miles from Earth, sending back detailed data about the oldest parts of the universe. Astronomers are using the JWST's advanced technology, like its sharp camera and special filters, to study the subtle colors around stars and planets. This telescope's ability to detect certain wavelengths of light helps scientists understand the physical and chemical properties of distant locations. The Webb telescope isn't just observing, it's actively searching for hints of life in other planets' atmospheres. Its discoveries, such as identifying hidden mass in the universe, have made scientists rethink their ideas about the cosmos. With each finding, our desire to learn about distant planets and the possibility of life deepens. New clues in the quest for aliens. Humanity is using the JWST to explore deeper into space than ever before, gathering information on remote worlds that could answer big questions about these planets. 2 decades ago, we knew little about planets outside our solar system, but since then, astronomers have discovered over 4,000 exoplanets orbiting distant stars. NASA believes these findings are just the start, with trillions of exoplanets potentially waiting to be found. Scientists are persistent in their quest to find planets that might support alien life. Occasionally, they stumble upon hints suggesting they might be on the right path. For example, when the Galileo spacecraft visited Jupiter, it accidentally found a potential sign of plant life, known as a biosignature. This discovery involved the vegetation red edge, VRE, which checks for life by analyzing how light reflects off it. The JWST, aided by the VRE, is well prepared to uncover more signs of life in space, mapping the orbits of planets in habitable zones around their stars. When these indicators appear, the VRE could significantly advance our search for intelligent life beyond Earth. This might trigger a new era of space exploration, leading us deeper into the unknown. As sunlight passes through various atmospheric layers of distant planets, it creates a unique spectral signature, a kind of fingerprint, that we can read using spectroscopy. Scientists believe that the JWST could be the key to understanding the composition of these planets' atmospheres. Planets similar in size to Earth typically have atmospheres containing carbon dioxide, nitrogen, and oxygen. The absence of more unusual compounds could suggest different life forms or even advanced civilizations. The James Webb Space Telescope's ongoing mission to explore distant planets continues to shape our understanding of life beyond Earth, revealing the secrets of our universe one discovery at a time. Take chlorofluorocarbons, CFCs, for example. These are human-made chemicals used mainly for cooling in fridges and in various industries. If the JWST spots these synthetic chemicals in a distant planet's atmosphere, it would be rock-solid evidence of intelligent life beyond our solar system. Such a discovery would really expand the scope for astronomers, giving them a whole new playground to explore the atmospheric makeup of other planets and even the slim chance of civilizations far beyond the Milky Way. Thinking about life beyond Earth opens up all kinds of possibilities that go way beyond what we see and experience in terms of biology right here at home. Often, we imagine life needing a nice, mild climate to thrive, but the reality could be far more varied and extreme. Take extremophiles, for instance. These are mostly bacterial life forms that toss our usual ideas of what makes a place livable right out the window. These tough critters manage to survive and even thrive in conditions that would seem downright apocalyptic to other life forms. They can handle boiling hot temperatures of up to 250 degrees Fahrenheit and can even thrive in super acidic conditions where the pH dips below 3. Their very existence is a powerful reminder of how resilient life can be, even under the most intense and unforgiving conditions. As the search for life-supporting worlds takes new turns, the possibility of finding life in unexpected places challenges what we know about the universe. Given this, the vastness and diversity of space really suggest that our search for life out there has to be broad and comprehensive. Planets that look a lot like Earth and orbit stars similar to our Sun are great places to start this kind of research. But it's also really important to keep an open mind and consider less typical scenarios, like exploring exoplanets that circle around red dwarf stars, which are pretty common across the universe. Even though these stars aren't as bright or warm as our Sun, they offer unique settings to check out life's potential in varied environments. The longer lifespan of red dwarf stars also gives plenty of time for the slow, intricate processes involved in the evolution of life to play out. Take the TRAPPIST-1 system, for example. It features a dim red dwarf star and 7 rocky planets, much like Earth, orbiting around it. Out of these, 3 are thought to be in the habitable zone, which means they could have liquid water on their surfaces. Despite being smaller and cooler than the Sun that warms our Earth, the TRAPPIST-1 star sends out a gentle light that could support life. By studying the light emitted by this star, scientists hope to unlock clues about the living conditions that might exist within the TRAPPIST-1 planetary system. After thorough research, the JWST figured out that this particular star is about 41 light-years away from us, located in the constellation of Leo, a promising spot for further investigation. Ward Howard, a NASA Sagan Fellow and the leading researcher on this study from the University of Colorado, Boulder, couldn't hide his excitement about these discoveries. He mentioned that thanks to the JWST, this is the first time we've had the ability to look for planets around other stars that have secondary atmospheres similar to what we have around Earth. He stressed how crucial it is to understand these stars to really get what's going on with their planets. Among all the stars scattered across the cosmos, Proxima Centauri really stands out due to its proximity. It's only about 4.25 light-years away from the Sun, making it the closest star to Earth. This star emits only a faint glow, which is tough to spot in the dark night sky from our planet. Its dimness means any potentially habitable planets would need to orbit much closer than Earth does to the Sun to keep conditions right for life. Back on August 24, 2016, astronomers stumbled upon something really cool, a planet with 1.3 times the mass of Earth, perfectly positioned within the habitable zone of Proxima Centauri. This zone strikes just the right balance of light, enough to melt ice and possibly give life a foothold. Proxima b, a fascinating planet that orbits the small red star known as Proxima Centauri, is situated a mere 4.6 million miles away from its star. This close proximity to its star subjects it to a variety of hazards that might make it difficult for life to thrive there. One major challenge is the intense solar winds from Proxima Centauri, which are powerful enough to potentially strip the planet of its atmosphere. However, despite these harsh conditions, Proxima b receives sufficient sunlight from its star, keeping the planet warm enough to maintain liquid water, a crucial ingredient for life as we know it. The close orbit of Proxima b around its star also results in a phenomenon called tidal locking. This means that one side of the planet always faces the star, receiving continuous sunlight, while the other side remains in constant darkness. This unique situation creates a stark contrast between the two hemispheres. One could be basking in perpetual daylight, while the other could be frozen in an eternal night. This is somewhat akin to the relationship between the Earth and the Moon, where the same side of the Moon always faces Earth. Despite the relatively small size of Proxima Centauri, it is still capable of emitting enough light and heat to potentially support an environment that could host life, not unlike conditions here on Earth. Are these strange city-like lights on Proxima Centauri b a sign of advanced alien life, or could there be another explanation we haven't considered yet? What do you think is the truth behind this discovery? Share your thoughts in the comments, and don't forget to like and subscribe for more.